Class 12, Chapter 5, Continuity and Differentiability. Exercise 5.1, first question. Prove that the function f of x is equal to 5x minus 3 is continuous at x equal to 0. So a function is given to us. We have to prove that this is continuous at the input x equal to 0. So the given f of x is equal to 5x minus 3. So here the degree of x is equal to 1. So we call this function as linear function, and it is also known as a polynomial function. We have to prove this function is continuous at x equal to 0. So to prove that the function is continuous, we know that when limit x approaches a, f of x is equal to f of a. So this is the condition we have to prove for a function to be continuous at a point x equal to a, right? But here the x value is equal to 0. So in the place of a, we will write limit x approaches 0, f of x is equals to f of 0. So if we prove that this LHS is equal to RHS, then it is clear that the given function is continuous at a point x equal to 0. Okay, so let us label this as 1. Now, the LHS of 1 limit x approaches 0, f of x is equal to, so in the place of f of x we will write 5x minus 3. Okay, and now we have to find the value of this limit. So in the class 11 we have studied that how to find the limit value. So we will break down this into two parts. One is left hand limit. The another one is right hand limit. When these two values are equal, we say that limit exists and the same value will be the limit of the function at the given point. So left hand limit, how do we write it? When limit x approaches 0 minus, so minus indicates the value is approaching from the left side, that I will explain in the graph. Now f of x is equal to limit x approaches 0 from the left. What is the function defined here is f of x minus 3. Okay, and how do we write right hand limit? Limit x approaches 0 plus, the plus indicates the input is approaching from the right side. F of x is equal to limit x approaching from the right, 5x minus 3 is equal to. Now we have to find what is the value of left hand limit and right hand limit. So we have studied that every polynomial function is continuous at a given point. So no matter what polynomial function you take, let it be linear, quadratic or any polynomial function, is always continuous at a given point. So directly we can find out the value. So this implies limit x approaches 0 from the left. So directly we will substitute 0 here. Minus 3 is equal to 5 times 0 is 0. 0 minus 3 is minus 3. So whenever you are substituting the value, you should not write limit here. You should write directly the real number. Now even this is a polynomial function, the same function. So directly we are going to find out the right hand limit. So 0 plus is equals to 5 times 0 minus 3. Now this is equals to 5 times 0 is 0. 0 minus 3 is minus 3. So when left hand limit is equal to right hand limit, so left hand limit is equal to right hand limit, we say that the limit exists. The limit exists. So if the limit exists, what is the value we will write? Therefore, limit x approaches 0, f of x is equals to limit x approaches 0, 5x minus 3 is equals to minus 3. Clear? Therefore, the value we can write here is minus 3. So the value of LHS is minus 3. Now we will see what is the value of RHS. RHS of 1. So what is RHS of 1 here is f of 0. So f of 0 is nothing but the functional value at x equals to 0. So when the input is 0, what is the output we are going to get? So when x equals to 0, f of 0 is equals to 5 times 0 minus 3, which is again minus 3. So if you observe here also we got minus 3 and f of 0 is also equals to minus 3. So what we can conclude from here, that the LHS is equals to RHS. Right? That is, limit when x approaches 0, f of x is equals to f of 0. Let us understand left hand limit and right hand limit graphically. So here we have taken x-axis where we see all the inputs, and the y-axis with the help of which we will plot a graph and get the outputs of the function. And this graph is f of x is equals to 5x minus 3. So here the given point at which we have to find whether the function is continuous or not is x equals to 0. So here 0 minus, in the sense we will approach 0 from the left hand side, right? We'll approach 0 from the left hand side, but we will never land up here. We are getting very close to 0, like 0.1, minus 0.1, minus 0.01, minus 0.001, minus 0.00001. So we will be approaching 0 from the left side. So if in that case, what is the functional value? Where do the function approach, or where do the outputs approach? That we have to find out. So let us take a very closer value, that is input minus 0.001. So if you give minus 0.001 as the input and you substitute in the function, you will get minus 3.005. Minus 3.005, which is close to minus 3. This number is very close to minus 3. Now if we take another number, minus 0.00001, which is even more closer to 0, then the output we will get minus 3.00005. So this table shows that as long as we approach 0 or we get very closer to 0, the outputs will get very close to minus 3. That's why we will write limit x tends to 0 minus f of x is equals to minus 3. It will not land up at minus 3, but it will get very closer to minus 3. Similarly, we will solve for right hand limit. Now let us approach 0 from the right hand side. So if you approach 0 from the right hand side, we want to know where does the output approaches to. So here I have taken the input x is equals to 0.001. It is positive because it is on the right hand side, we get all the positive numbers. and if you substitute f of 0.001 in the function, the output will be minus 2.995. 2.995 is quite closer to minus 3. Now let us approach 0 by taking another number 0.00001, which is even more closer to 0 than 0.001. So what is the value we will get? F of 0.00001 is equal to 5 times 0.00001 minus 3 is equals to minus 2.99995, and this number is even more closer to minus 3 compared to minus 2.995. So it shows that if you approach 0 from the right hand side, the output approaches towards minus 3, right? From the left hand side also you're getting minus 3, and from the right hand side you're also getting minus 3. So that's why we'll write limit x approaches 0 plus f of x is equals to minus 3. Since both the cases are true, both the cases are equal, we say that the limit exists and the limit of the function is minus 3. So this is how we got the answer graphically, but in the exam you can just mention the theorem, and if it is a polynomial function you can substitute directly and can get the answer.